Hello everyone, welcome back to my channel. Today we are diving into a fascinating coding challenge from LeetCode number 2058 called Find the minimum and maximum number of nodes between critical points. This problem falls under medium category and focuses on linked list, a fundamental data structure in computer science. So let's first understand what they mean by critical points in a linked list. A critical point is defined as either a local maximum or a local minima. A node is a local maxima if its value is strictly greater than the value of the node that's directly before and after it. Conversely, a node is a local minimal if its value is strictly smaller than its neighbors. It's important to note that a node can only be a local maximum or minimum if it has both previous and next node, which means endpoints of linked list cannot be critical points. Also, we are given a linked list head. Our task is to return an array of two integers. The first integer is the minimum distance between any two distinct critical points, and the second integer is the maximum distance between any two distinct critical points. And if the maximum distance between any two points, if there are fewer than two critical points, we will return -1 and -1. So let's check a few examples. In the first example, as we see the 3 and 2, it is impossible to create any critical points, so result will be -1, -1. In the second example, we can have an output of 3 or 2, and there is possibility to create a critical points at the C with 1, where 3 and 2 are more than 1. And also it's possible to make it with 6, where the 5, for example, is the biggest, because 2 and 1 less, and 3 and 1 is also less than 2 and 5. Also we had another example where it will be 3, the possibility to use 3 and 3, as both of them are bigger than their neighbors, the list node. So let's discuss our solution process. First of all, we will start by setting up pointers and variables. It will help us to store the values of previous node and indicates for the first and the last critical points, and a variable to track the minimum distance between the critical points, which will be initialized to infinity. Then we will track the linked list using a loop to go through each node of the list. For each node, we will check if it's critical points by comparing its value with the previous and the next node's value. Then we will track critical points. If we will find a critical point and it's not the first one, we will update the minimum distance by comparison it with the difference between the current and the last critical point. Otherwise, we will mark it as the first critical point. After which, we will update variables, processing a node to the previous variable to the current node value and move to the next node. After it, we will calculate the distance, and once the loop is completed, if at least two critical points were found, return their minimum and maximum distance. If fewer than 2 were found, we will return -1 and -1. So let's start by initializing variables. We'll use let. First will be min distance, which will be set to infinity. Then another one will be prev, which means the previous node. For comparison, it will be set to the head. Well, and we'll use index, which will be set to the 0. it will help us to track the current node's position in the list. After it, we will set up first and last critical node to store the indexes of critical points that we will find. First critical, it will set null, and last critical we also will set to the null. Then we will show the linked list starting from the second node. So it's 4. That node will be equal assigned to head next, then node next, after it node assigned to node next, and index increment. Then we check the current node's critical points. A critical point is either local or maximum, or minima. So if you create node val is more than 3 and node val is more than node next val, after which we will compare it to another node val will be less than preview, and node val less than node next well. Then if it's not the first critical points encountered, we will calculate the distance from the last critical point and update the mean distance. So first critical wouldn't be equal to null, then distance will be updated by using match math mean distance index minus last critical point. Then if it's a first critical point, we will store its index and we will update the last critical to the current index every time a critical point is found. Critical will be updated the index. After it, we will update the proof to the current node's values for the next iteration. After looping through, if we have at least 2 critical points, we will return an array containing the minimum and maximum distance between critical points. Otherwise, we will return -1 array, indicating no valid critical points were found. For it, we will use a return statement with comparison. So first critical wouldn't be equal to null, and first critical isn't equal to last critical operational. This array of mean distance last critical minus first critical, and otherwise we just return an array of -1 -1. So let's run code, work, and submit. So, to wrap it up, this problem is a great experience to enhance your understanding of linked lists and how to manipulate pointers with them. It also tests your ability to implement coding logic and efficiently in a coding environment. It's all for today. Thank you for your attention. Please like, subscribe, and leave comments below. Goodbye.